So in probability, today we go for a few more problems, where one of the problem is relating to the cards, playing cards, speed. Okay, so that cards contains total 52 cards, right? And in these 52 cards, again we can divide them in four, as there are four different types of cards are there. And when we go to colors, two colors, so two red colors and black color, two. Okay, and in red here again we can divide heart and diamond. And in black color again two types are there, so spades and clubs. And clubs. And in each of these there are 13 cards. 13 into 4, 52 cards. Okay, so what are those 13 cards? So those 13 cards are number 2 to 10, and one card is named A, that is ace, and the next card jack, that we call it as a joker, and the next queen and king. Okay, so these are the 13 cards we have in speed cards in a pack of 52 cards deck. Okay, so problems relating to this, if you understand these here, okay, ace, 4 cards, 1 in each, king, again 4 cards, 1 in each, queen, 4 cards, and jack or joker, 4 cards in each of these 4 cards, and remaining number from 2 to 10. 2 to 10, 9 cards is 10, 11, 12, 13. So 13 into 4, 52 cards. If you remember this much information, you can solve any problem relating to cards in probability. Okay, so today we'll take one first simple problem on cards, playing cards. Then we'll go for difficult one. Okay, so in a card, so 52 out of 52 cards, a card is drawn from the pack of 52 cards, and what is the probability that the drawn card is? So drawn card is first club and second king. So first question is relating to the club, second question is relating to the king. Okay, now here, so out of 52 cards, how many are club here? So clubs means here total 13 cards are there. Black color, okay, so leaf shaped card, total 13 card. And king, how many king cards are there? Total 4 king cards in each, heart, diamond, spade and club, that is 2 red king cards and 2 black king cards, total 4 cards. Okay, out of how many cards? Out of 52 cards, 13 clubs and 4 king cards. Okay, now let us solve this problem. So here we'll name the event, instead of A, B, we'll name them with the first letter of the card's name here. So first one, club, they are asked. So here let C be an event of selecting club, and let K be an event of king. Okay, so here how many clubs are there? Total 13 clubs and 4 kings. So club cards 13 in number and king cards are 4 in number. So probability of selecting a club card, probability of C is equal to, formula first, M by N, that is we can say, or we can write in another form, that is number of club cards divided by number of sample space. So that is 13 cards are relating to or favorable to event selecting a club card, and exhaustive cases 52 cards. So 13 divided by 52. So we can write 1 by 4 or equal to 0.25. So selecting a club card is 1 by 4 or 0.25. Now second question, king card. The selected card may be king. So probability of K, P of K is equal to M by N, or N of K, favorable cases to king card, divided by favorable cases of exhaustive cases. So here 4 king cards divided by 52 cards, that is equal to 1 divided by 13. 1 divided by 13. Okay, so if we write it in decimals, 0.0769. Now next problem, where 2 cards are drawn. Okay, so in last problem we see 1 card is drawn. Now we go for 2 cards, drawing 2 cards. So I will read the problem. 2 cards are drawn from the pack of 52 playing cards. What is the probability that they are kings? First question, kings, and second question, hearts. Okay, so again here, first question is kings, that is both are kings. Second question, hearts. Okay, now here in this problem we are drawing 2 cards, and there are 52 cards, 4 different types. In each 13 cards are there. So I think you remember the problem we solved yesterday of balls in a bag, different color balls in a bag. So in the same way you have to select here. So here we know that 4 kings are there, 4 king cards, 2 red and 2 black, 2 red kings and 2 black kings. So out of these 4 cards we have to draw 2 king cards, and in out of how many cards these 4 are kings here? In out of 52 cards we are drawing 2 cards. Okay, so out of 52, 4 are kings. Out of 52 we are drawing 2 cards, and out of 52 cards only 4 are kings. Out of 4 kings we have to draw 2 kings here. Okay, and second question, hearts. How many hearts are there in the cards? So total 13 hearts. Total hearts are 13. Okay, so heart means only one single type. Heart shapes, red cards, total 13 are there. Out of these 13 cards we have to select 2 cards. Okay, so now here probability is not that easy as we solved as just previous problem. Here we have to go for combination. Okay, so in those 2 cards, in how many ways we can draw? Those 2 cards, in how many ways we can draw here? Because selecting 1 card out of 4, 1 card is in 4 different way we can select. But selecting 2 cards out of 4 cards, so again ways will differ here. Okay, let us see here. First let the event let K be an event of getting 2 kings, and let H be an event of getting 2 hearts. Okay, 2 kings and 2 hearts. So total how many kings are there? Kings total 4, out of which we are drawing 2. So that means here in 4C2 ways we can draw 2 king cards. And how many are hearts here? Hearts are 13 and we are drawing 2 cards. Means in 13C2 ways we can draw 2 heart cards. And these two processes, in how many cards we are drawing? So that is exhaustive cases. Exhaustive cases is 52. Out of 52 cards we are drawing 2 cards. So 52 C2. Selecting a heart 4C2. Selecting kings 4C2. Selecting heart 13C2, and out of 52 cards we are drawing those 2 cards. So exhaustive case is 15C2. So probability of getting a king card P of K is equal to here 4C2. In 4C2 ways we can get king cards divided by 52C2 ways we can get 2 cards. Okay, so now here what is the answer for 4C2? In how many ways we can draw 2 cards here? So 4C2, 4 into 3 into 2 factorial divided by 2 factorial into 2 into 1. So 2 factorial cancels. 2 ones are 2 2s are 2 into 3 6. So in 6 ways we can select king cards. And 52C2. So 52 into 51 into 50 factorial divided by 2 into 1 factorial, 2 into 1 into 50 factorial, that is 52 minus 2. 50 factorial cancels. 2 ones are 226. So 26 into 51, that is 1326. So the answer of selecting 2 king cards is 6 divided by 1326. So finally we can arrive to the answer. You can keep the answer in this manner only, or else you can write it in decimal form. So 6 divided by 1326, how much? 0.0045. Okay, and now will you calculate second one and will you tell me the answer first? What is a complementary event? A complementary event is one which stops occurring of another event. For example, A is equal to 1 2 3, sample space 1 2 3 4 5 6. Then complementary event to A event. Complementary of A event, A dash is equal to 4 5 6. Okay, and in the probability, remember always probability, total of a probability for any trial you take, that will be equal to 1 always. For example, so when we throw a die, we may get 6 outcomes. Out of these 6 outcomes, any outcome we may get. Okay, so probability assigned to each of them is 1 divided by 6. So getting probability of getting 1 is 1 by 6, getting 2 is 1 by 6, getting 3 is 1 by 6, getting 4 is 1 by 6. 5 and 6, they are having probability 1 by 6. So 1 by 6 plus 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 1 by 6. So all the denominators are 6 only. So 6. Add all the numerator, 1 plus 1 plus 1 plus 1 plus 1 plus 1. So that is 6. So 6 divided by 6 is equal to 1. So always the total of probabilities to an event is 1. If we take another example of coins, so when we toss a coin, we will have two outcomes, that is one is head and another one is tail, and probability assigned with getting head is 1 by 2, and probability of getting tail is also 1 divided by 2. So that is denominators are same, so 1 plus 1 is 2, 2 divided by 2, that is equal to 1. Now when it comes to the complementary event, if you take the same example, so event A is equal to 1, 2, 3, and complementary event A dash is equal to, so apart from these, whatever is there in the sample space, that is 4, 5, 6. Okay, so now probability of getting event A, is how many favorable cases are there here? So that is m is equal to 3 here, or you can say n of A. And exhaustive cases, so that is n of s is equal to 6. Now here A dash, so here m or n of A dash is equal to 3. So probability of these two will make a total equal to 1 or no. Let us check. So probability of getting event A is 3 by 6, or you can put it in the simple form 1 divided by 2. Probability of A. Then probability of A dash is equal to, so how many favorable cases are there for complementary event? 3. So 3 divided by 6 is equal to 1 divided by 2. Then total of these two events, as we know, all the cases, all the events in sample space are covered by these two events, event A and complementary event A dash. Okay, so P of A plus P of A dash is equal to 1 divided by 2 plus 1 divided by 2 is equal to 2 divided by 2, that is 1. So considering this here, our next problem, okay, so that is in a playing cards. Again we go for playing cards problems only today. So in a playing cards, what is the probability of getting an ace, and what is the probability of getting not getting an ace? Okay, so first question, getting ace. Second question, not getting ace. So ace, how many ace are there in a playing cards? In a playing cards, there are total 4 ace, 2 in red color and 2 in black color. Okay, so here getting an ace. So let probability, let A be an event of getting ace. Then P of A is equal to, there are total 4 ace cards, 4 out of 52 cards we are selecting 4 ace cards. So P of getting ace is 4 divided by 52, that is equal to 1 divided by 13. Now second question, not getting an ace. Okay, so not getting an ace means it's a exactly complementary event of getting ace. Okay, they both are mutually exclusive. If not getting an ace, that event comes, getting ace will not come. Okay, so here second question, not getting ace is P of A dash is equal to 1 minus P of event A. So 1 minus P of getting A. So 1 minus 1 divided by 13. 1 minus 1 divided by 13 is equal to 12 divided by 13. So P of not getting an Ace card is 12 divided by 13. So when a coin is tossed, what is the probability of getting head and what is the probability of getting tail? So these two already we solved and it is quite easy also. So when we toss a coin, we get two outcomes. One is head and one is tail. And now probability of getting head is 1 divided by 2 and probability of getting tail is 1 divided by 2. Now third question. What is the probability of getting either of this, head or tail? Probability of getting head is 1 by 2. Probability of getting tail is 1 by 2. Then what is the probability of getting either head or tail? So here, not 1. Okay. So this comes here, addition theorem. So when the events are mutually exclusive, the events are mutually exclusive. If we get head, we don't get a tail. If we get a tail, we don't get head. So these two events are mutually exclusive and both are equally likely events. The chances of getting head is the same as the chances of getting a tail, 1 by 2. Okay, so equally likely and mutually exclusive events. Okay, even they both are here complementary. Got it? So when mutually exclusive cases are there, addition theorem tells that P of A or B or probability of A plus B, or you can write again P of A union B, either of these events. By these three symbols we can represent it: A or B, A plus B, or A union B. So probability of A or B is P of A plus P of B. Probability of A plus probability of B. So out of two outcomes, that is head, tail. So this is sample space and probability of getting head is, so here n is equal to 1, here n is equal to 2, or you can say here n of s is equal to 2, n of head is equal to 1. So tail, that is t. So here again m or n of tail is 1. So probability of getting head P of h is equal to, so n of h divided by n of s, that is 1 divided by 2. Okay, and probability of getting tail is equal to n of t divided by n of s, that is again 1 by 2. Now probability of either head or tail. Probability of head or tail, that is P of A or, sorry, P of here H or T is equal to probability of head plus probability of tail. So getting either head or tail. So that is P of head is 1 by 2 plus P of tail is 1 by 2. So probability of getting either head or tail is equal to 1 by 2 plus 1 by 2. So denominator is 2 common. So 2. So 1 plus 1, 2. That is equal to 1. So probability of getting either of them is 1. Got it? So in the same way, now we'll go for a little difficult problem. So where combination comes, balls problem. Okay, so this one clear? Okay, now we'll go for the next problem. That is a bag. A bag contains 6 black balls and 4 white balls. 6 black balls and 4 white balls. 2 balls are drawn at random from this bag. How many? 2 balls are drawn from the bag of 10 balls. Among 10 balls, 6 are black and 4 are white balls. Now, what is the probability of they both are black ball and they both are white ball? And the third question is one black, one white ball. Not either of. One black, one white. Here addition theorem doesn't come. Remember. Okay. So first question, both black ball. Second question, both white ball. And third question, one black and one white. Okay. So this comes in multiplication theorem. Either white or black. So that means both are white or both are black. That comes under addition theorem. Okay, now this one white and one black ball. So this comes under multiplication theorem. In detail, we discuss both addition theorem and multiplication theorem in next class. Just here, look at this. This is a simple problem. We can solve it directly here. Okay, now here, how many balls are there total? So number of balls, 10. Okay, out of 10, 6 are black, 4 are white. Now let event B be selecting a black ball and event W be selecting a white ball. So let event B be selecting black ball and let event W be selecting white ball. Okay, now probability of getting black ball, P of B is equal to, so here we are selecting 2 balls. Okay, out of how many balls? Out of 10 balls. So exhaustive cases is 10C2. So exhaustive cases is 10C2. Out of 10 balls, we are selecting 2 balls. Now favorable cases to selecting black balls. So how many black balls are there now? Only 6 black balls are there. Out of 6, we have to select 2 black balls. So 6C2. So probability of selecting black ball is 6C2 divided by 10C2. So now 6C2, 6 into 4 into 5 factorial divided by 2 into 1 into 5. 6 minus 2 is, sorry, yeah, 6 into 5 into 4 factorial divided by 2 into 1 into 6 minus 2 is 4 factorial. So 4 get cancelled. 2 ones are 2 threes are 3 into 5, 15 divided by 10C2. So 10C2 is 10 into 9 into 8 factorial divided by 2 into 1 into 10 minus 2 is 8 factorial. So 8 factorial got cancelled. 2 ones are 2 fives are. 5 nines are 45. 45. So probability of selecting black ball is 15 divided by 45. That is equal to 1 by 3. 1 divided by 3. Now the second question. What is the second question? Both are white balls. So probability of selecting white balls, P of W is equal to. So in how many balls are there? 4 white balls. So selecting 2 balls out of 4 white balls is in 4C2 ways we can select. So 4C2 divided by 10C2. So 4C2 is 4 into 3 into 2 factorial divided by 2 into 1 into 4 minus 2 is 2 factorial. 2 factorial get cancelled. 2 ones are 2 twos are 2 into 3 6. So 6 divided by 45. 6 divided by 45. So 6 divided by 45, you can keep that as it is, or even you can reduce it. So 3 15s are 3 2s are 3 15s are. Okay, so 2 divided by 15 is the probability of getting white balls. Now the third question. So third question is, one is black ball and one is white ball. So probability of, here multiplication theorem, you can write that as black ball and white ball. Okay, or even you can write it as a probability of B into W, or probability of B intersection W. So that doesn't come. Okay, probability of one black ball and one white ball is equal to, so in how many black balls you have to select one ball here? 6 black balls. So 6C1 into, out of 4 white balls you have to select one. So 4C1 divided by 10C2 is equal to, so 6C1 is 6 itself into 4C1 is 4 itself divided by 10C2. So we are selecting 2 balls only. Remember that we are selecting 2 balls only, but one is white and one is black. So that is 45. So that is 20. 6 into 4, 24 divided by 45. So 24 divided by 45. So even if you reduce it, you get 0.533. So probability of getting one black and one white ball is 0.533, or 24 divided by 45.